Hi everyone. In this short video, I will explain how you conduct a power analysis to estimate the necessary sample size to detect a true effect or relation if it actually exists. So, what actually is a power analysis and why is it necessary? In general, we can define statistical power as the probability of a test to detect an effect if there actually is an effect, if there is a true effect. The main goal of a power analysis is to estimate the sample size for our study that is necessary to find the hypothesized effect if it actually exists. In other words, we want to calculate how many participants we need in our study before we actually conduct or run the study. Because if our sample size is not large enough, we might fail to find an effect, ultimately leading to false conclusions. Knowing this, we need to ask ourselves which factors actually can affect the statistical power of our hypothesis test. First, the sample size is relevant. The larger our sample, the higher the statistical power of our test. Second, statistical power depends on the effect size. Larger effects are usually easier to find or detect. Third, the significance level, or the alpha level, which is commonly 0.05 in psychology, also plays a role. If we actually decrease the significance level, so for example from 0.05 to 0.001, which some researchers have argued we should do, the statistical power of our test actually goes down. And then at last, the variance in the effect size or in the data distribution also matters. If there is more variance, then statistical power actually suffers. Let's illustrate this and statistical power with an example. So imagine we have the situation that we want to test the effectiveness of a leadership intervention aimed at increasing followers' job satisfaction, comparing an experimental with a control condition. So we have an experimental condition where leaders get a training, and the idea is that this training then ultimately increases followers' job satisfaction. Whereas in the control condition, the leaders get some sort of fake treatment, but not actually a leadership training. We then find the following means. So we have in the control group a mean of 3.56 and a standard deviation of 0.65, and in the experimental group the mean is 3.75 and a standard deviation of 0.067. So at face value, it looks a bit like the experimental group has a slightly higher mean, which could indicate that the intervention was effective, but we actually want to test if these two groups differ significantly from one another. And so if we have two different scenarios. In the first scenario, we just have 20 participants in each of the groups, so 40 participants in total. And we can see here that the t-test that we can conduct to compare or to test if these two means differ significantly from one another is actually non-significant. We have a p-value of 0.185, which is above the common significance threshold of 0.05. However, in the second scenario, we have 100 participants in each of these groups. We have the same two means, but we can see that now they actually differ significantly from one another. The p-value here is 0.022. So in other words, what this shows is that only in the second scenario, where we had 200 instead of 40 participants, only the second scenario had sufficient statistical power to test if the intervention was actually successful in achieving its aims. And so it shows that power is dependent on the sample size, for example. Having illustrated what power is and why it is relevant, let's look at what we need to know to conduct a power analysis. First, we need to know the test that we want to conduct. This can be a correlation analysis, a regression, or a mediation analysis. Second, we need to know the significance level. We can just here follow the common conventions of p smaller than 0.05. Third, we need to decide how much power we actually want. Common thresholds or common values are 80% or 95%. It doesn't really matter if you use 95%, you're more sure that you can actually find an effect if it actually exists. But ultimately that comes down to practical considerations as well, because using 95% of power always means that you need to collect more data, and that in some cases is difficult or expensive or maybe sometimes even impossible. So 80% is also fine. At last, we then need an estimate of the population effect size. In other words, we need an estimate of the magnitude of the effect size that we actually expect to find or that we want to test. This can be a bit tricky, but there are multiple ways to estimate this. First, we can try to locate meta-analyses that have already examined our relation of interest or a very similar relation and use this meta-analytic effect size. Second, we could also use an effect size from a recent study. Doesn't necessarily have to be recent, it can also be any study, but the more recent, the better it would be. If one of these two A and B ways here are the most optimal ways, if that is not successful, we could also conduct a pilot study ourselves, meaning that we run a study with a very small sample just to estimate the strength of the relation between two variables, not caring that much about statistical significance, or not caring at all about the statistical significance, but we really just want to have an insight into the magnitude of the correlation. It is not super reliable, but it could be done. However, in our case now in this practical here, this is actually not a realistic option because we don't have the time to do this. But I want you to know this, that this would be a possibility nevertheless. And at last, we could use general guidelines for effect sizes, such as the ones from Cohen, and then make a reasonable or educated guess about the effect size that we expect to find, the correlation that we expect to find. I know that guidelines from Cohen actually say that a small effect size is 0.1, a moderate one 0.30, and a large one 0.50. I think it's much more realistic in psychology to speak of small correlations as 0.1, moderate as 0.20, and large as 0.30. So this is why I use this, and I would like you guys to stick to these guidelines here as well. Again, note that you should first try to find a meta-analysis, then a recent study, and if that doesn't fail, then in our case, we would actually rely on these general guidelines for effect sizes. So, let's begin with a power analysis for a simple correlation. To do this, you can download a software called G-Power using this link here. The software then looks something like this, where you need to select a few things. So the first thing that you need to choose is exact under test family, and then you should choose a priori compute required sample size given alpha power and effect size. We want to choose a one-tailed test because we usually have an expectation about the direction of the relation, and then we want to include the best estimate for the correlation. In this box here, I included 0.30 here. This is what I was talking about on the earlier slide. So let's say this is we want to examine if conscientiousness relates to job performance. Then we could locate a meta-analysis, and we would likely find that this correlation is somewhere around 0.30. I don't know for sure. I just put in something here now. This is the correlation that we would include here. Then the alpha level is 0.05, so that's the significance level. I used 95% power here, and the correlation for the null hypothesis is 0 because we always test an alternative hypothesis. There is a significant correlation, positive correlation between conscientiousness and job performance, versus the null hypothesis. There is no significant relation between these two variables, and that is usually then 0. Then we can just click on calculate on the bottom right, and the result here now for a correlation of 0.30 would be we need 115 participants. You can also see this in the software output on the right where it says total sample size 115. What you can also see here is I included results for different levels of this correlation to show you that the necessary sample size depends on the strength of the correlation between the two variables. And so we can see here that for small correlations, for example, R.1, we actually need a lot of participants, more than 1,000, but for really, really strong correlations of 0.50, we just need 38 participants. So you can really see that, again, the required sample size depends strongly on the strength and magnitude of the correlation that we expect to find. Now, let's turn to power analysis for mediation. This is a bit more complex, but essentially it's an extension of the power analysis for a correlation. You can conduct this power analysis for a mediation using the Shiny app included in the link here. which is also based on this citation here that I included on my slides. Yeah, as I said, a power analysis for a mediation is essentially a straightforward extension of the power analysis for a correlation, with the main difference being that you need effect size estimates for the relations between all variables in your model. So we have 3 variables here in this model, x, y, and then the mediator, and we need to have estimates for all correlations that we expect to find here. The goal here is then to estimate how many participants we need to have we are required to include to have enough or sufficient power to detect an indirect effect or a mediation. So to test if the relation between x and y is mediated by m. This is called AB in the output, because the A path is usually the relation between the independent variable and the mediator, and the B path is the relation between the mediator and the dependent variable. Once you get to the Shiny app, it looks something like this here on the slide. You choose a model with 1 mediator here, and you want to select set power vary n. The target power can then be 0.80 or 0.95. Again, I used 0.80 in this case now. And then you need to tell the app for which values of the sample size it should calculate the power. I now here used a range from 50 to 400. It's a bit of guesswork, and you might have to play around with this a bit to get the right values on the right. I'll come to this in a second. Everything else on the left-hand side of this website can basically stay the same. In the red box here, oh, I forgot these arrows. These are the arrows that we need to change, and everything else can stay the same. In this red box here, you then need to insert estimates for the relations between all variables, which we can get from, again, meta-analyses, earlier studies, a pilot study, or which we can guess based on small, moderate, or large effect size guidelines. I included random values here now, 0.28, 0.21, and 0.33. The standard deviation can be set to 0.5 or 1. This actually does not change the results of the power analysis a lot, so keep it at 0.5 or 1, doesn't really matter. We can then calculate power to run the power analysis, and then the output on the right provides the power values for all sample sizes in the range that we included. So here I used 500 to 50 to 400, and the output then reports the achieved power at different levels of the sample size. We can then find the sample size necessary to achieve 80% power by scrolling through that output. This is what I'm talking about. In this case, 80% power actually ranges from 129 to 131 participants. In other words, we need approximately 130 participants to detect a mediation here, if there truly is a mediation. Yeah, here we can see this. So, at last, let's have a look at how we can conduct a power analysis for a moderation analysis. There is again a Shiny app that we can use. The link is included here. The reference is also included here. And the Shiny app, at least the left-hand side of that website that opens, then looks something like this here. We can again keep everything as it is in the first 4 boxes. In the sample size box, this here, we can include multiple values for which we want to estimate power. I used, in this first step, 100, 150, 200, 250, and 300. To conduct this power analysis, we then need to estimate 4 effect sizes. First, we need a correlation between the independent variable and the dependent variable, so IV and DV, which can usually be found using, again, either meta-analyses or prior studies. The same holds for a correlation between the moderator and the dependent variable, which is usually easy to find. And then we also need a correlation between the independent variable and the moderator, which we can usually locate in prior studies as well. At last, and now here it gets a bit tricky, we need a correlation between the interaction effect and the dependent variable, which is really rather difficult or likely also impossible to find or to locate, because these are usually not published in scientific articles. What we should then do instead is to run the power analysis at different values of this correlation. In other words, we can repeat this power analysis 3 times, once for R.1, once for R.2, and once for a correlation of 0.3. We then get different necessary sample sizes depending on the expected magnitude of the correlation of the interaction with the dependent variable, which we can then report in the method section. I will show you how you can do this on the next slide. Once we have included all of this information in the Shiny app, we can conduct the analysis. There are a few additional things that can be included further below or changed further below in the output, which is not shown on the screenshot here, but you can just keep the default values there. If we now run the power analysis with the included values, we get this output. Here we can see that we need somewhere between 150 and 200 participants to achieve 80% power. Yeah, so for 150 the power would be 70.3%, and for 200 it would be 87.1%, so we can already see that it must be somewhere in that range if we want to achieve 80% power. We can then refine the sample size values to a range between 150 and 200, so we can change this in the output here, in the input here. And if we then run this analysis again for 150, 160, 170, 180, 190, and 200, we get this output. And we can now see that to achieve 80% power, it needs to be somewhere between 170 and 180 participants, probably a bit closer to 170 participants. So I ran this analysis again for 170, 171, 172, and so on. And we can then see to achieve 80% power, we actually need 174 participants. This is a bit repetitive. It's a bit of a tedious task. You need to play around a bit with it, but ultimately it shouldn't take you too long. Then what we actually want to report again here is how many participants we need to achieve 80% power in this case. Importantly, we will then repeat this analysis for weak and strong values of the correlation between the interaction and the dependent variable. Remember that here for this correlation I now used R.20. We should repeat this entire analysis again for R.10 and R.30. Yeah, that's the power analysis for moderation. On this last slide, I have included sample texts that show you how you can report the results of your power analysis in your report. More specifically, this paragraph needs to be included in the method section of your report, possibly before describing the participants of your study. Note that I did not discuss this in the video about the introduction and method section because we hadn't talked about the power analysis yet, and so it's not listed in there, but please remember that this should actually be part of your method section. No, I will also not go through these 3 different texts here one by one. You can read them yourselves, you can pause the video, you can download the slides and then read through them in detail. But what's important is that you always need to mention the following things for all three different analyses that you could potentially conduct. You need to mention the software that you use to conduct the power analysis, including a scientific reference. You need to report the population effect size estimate or estimates that you use. So depending on, for the correlation, it's just one, and for mediation and moderation, it's multiple ones. That also needs to be accompanied by a reference. So if you used an effect size estimate from a meta-analysis or a prior empirical study, you need to report where that effect size comes from. You need to use report the significance level, which we now keep constant at 0.05 always. You need to report the desired power, 80% or 95%, and then you need to report the results of the power analysis. In other words, the required sample size, or the sample size that is required to achieve sufficient statistical power. Note, remember that for the mediation and for the moderation, you need to report multiple population effect size estimates. And for the moderation, you also report results at 3 different hypothetical levels of the correlation between the interaction and the dependent variable. At last, please make sure that you do not copy-paste the text that I wrote here. You need to write this in your own words to avoid plagiarizing my text. So that's the end of the video. I hope the video really helps you to properly conduct a power analysis, to understand a bit what a power analysis is, why it is important, and then especially how to conduct it for either a correlation, a mediation, or moderation analysis. And I hope that I explained everything clearly. In case you still have questions, maybe watch the video again, and if you then your questions persist, then obviously feel free to talk to us during the practical, or if we're not in a practical meeting, you can always ask questions on the Canvas discussion forum. Thanks for watching, and good luck conducting the power analysis.